My name is Alois Pantoja,
I'm Jesse Torres.
and this are
My question is, how does the grip, pressure, and arm angle allow a 5-ounce baseball to curve? So the first thing you need to know is the grip of a curveball, which is high pressure on the middle finger and index next to it for control, like this.
When throwing a curveball, your arm angle has to be at 120 degrees, which causes a 5-ounce baseball to have a natural curve.
So for our example, we drew a diagram of the pitcher's mount and the home plate, which having the starting point right here and the ending point, which is the opposite end of the home plate. So YP stands for half the distance of the home plate, and YD being the total distance, which means the starting point and the ending point of the arc of curvature.
To solve our equation, we're going to need the distance between the pitcher's mound to home plate, which is 60.5 feet or 18.44 meters. We will also need to find force, mass, acceleration, and velocity.
Alright, so an example of how the grip, pressure, and arm angle allows a 5-ounce baseball to curve, we would be giving an example of a 5-ounce baseball is going 30 meters per second with a force of 4.26 newtons and reaching a distance of 18.44 meters. With the arc of curvature is blank.
To solve our example, we will have to use Newton's second law, which has two equations: r being radius of curvature over velocity squared divided by acceleration, and the second equation being acceleration equals force divided by mass. How we decided to find the value of force, which we already have the value of our mass and acceleration. Our acceleration being 30 meters per second square, and our mass being 5 ounces, which we converted into kilograms, which is 0.142 kilograms. And once to solve for it, we had to multiply 30 meters per second square times 0.142 kilograms, which gave us the amount of 4.26 newtons, which that's our force.
So now that we found the force, mass, and acceleration, we need to find velocity. So that's simple by finding the top speed of this curve is 85 miles per hour, and 85 miles per hour converting to meters per second is 38 meters per second. So next thing we need to do is find the radius of the curvature, which is velocity squared over acceleration. So we just simply plug in numbers, which is 38 meters squared per second squared over 30 meters per second squared. So once this is put into a calculator of 1,444 meters squared over second squared divided by 30 meters second squared, you get 48.13 meters. Alright, so in case you guys don't know what the radius of a curvature is, imagine this curve on a circle. We are finding the distance of the starting point and the ending point of that curve. So the radius of curvature is the middle of that circle.
Now that we found our radius of curvature, we will have to find the arc of curvature, which to find this, we will have to use a trigonometry equation, which is arc of curvature equals radius of curvature minus the square root of radius of curvature squared minus distance squared. Once you apply all the numbers which we have here listed, you get an answer of 48.13 meters minus the square root of 48.13 meters squared minus 18.44 meters. We have applied all of our substitutions into the equation. Our arc of curvature would be 3.66 meters, which that means from your starting point where the pitcher releases the ball to your ending point, 3.66 meters. That's how much distance the ball traveled across home plate.
Alright, so in this particular equation, spin or wind was not a factor into the curveball, but spin does have a factor on the curveball. When the ball is released, high pressure of wind is placed on top of the ball and low pressure is placed on the bottom ball, allowing the baseball to also curve.